On July 10th, 2025, something extraordinary happened. Earth spun faster than ever before in recorded history, surprising scientists and sparking curiosity around the globe. On that day, our planet completed its rotation 1.36 milliseconds quicker than usual. It might sound like an almost invisible change, but in the world of science, even the tiniest fractions of a second can reveal big mysteries. That's barely a blink for us, but for scientists, it's a significant event, one that challenges what we thought we knew about our planet's rhythms. For millions of years, Earth's rotation has been gradually slowing down, mostly because of the moon's steady tidal pull, which acts like a cosmic brake. But suddenly, this ancient trend reversed. Why did our planet speed up, even if just for a moment? The answer isn't simple. Thanks to atomic clocks, devices so precise they'd lose only a second in millions of years, we can detect these minuscule changes in Earth's rotation with incredible accuracy. This anomaly hints at powerful forces at work, shifting mass both inside and on the surface of our planet. It's a reminder that Earth is alive with movement. Imagine a figure skater pulling in her arms to spin faster. Earth does something similar, but with glaciers melting, magma flowing, and even dramatic weather patterns swirling across continents. These subtle shifts, though almost invisible to us, are signatures of vast, unseen movements deep beneath our feet and across the planet's surface. It's not just a quirky fact for trivia night, it's a vital clue that our planet is more dynamic, unpredictable, and interconnected than we ever imagined. The shortest day ever recorded is more than a record. It's a sign that Earth's story is still unfolding, full of surprises waiting to be discovered. A millisecond may seem trivial, almost too small to matter in our daily lives, but in the realm of technology, even the tiniest fraction of a second can have enormous consequences. Our digital world runs on perfect timing, with millions of devices and systems relying on precise synchronization to function smoothly and efficiently. Systems like GPS and the internet depend on coordinated universal time, UTC, staying in sync with Earth's rotation. Without this harmony, global communication and navigation would quickly unravel. Even a tiny drift can throw off navigation, disrupt financial trades, and break security protocols. The stakes are high and the margin for error is razor thin. That's why we have leap seconds, to keep atomic time and Earth time aligned, ensuring that our clocks match the planet's natural rhythm. For decades, we've added leap seconds as Earth slowed down, making tiny adjustments to keep everything in sync. But now, with Earth spinning faster than before, we might need to subtract a second, a negative leap second. This is something the world has never had to do. This is uncharted territory for programmers and global infrastructure who must prepare for challenges no one has faced before. A single millisecond's difference can ripple out, causing chaos in systems that demand absolute precision, from hospitals to stock markets. The world's digital heartbeat depends on our ability to keep up with a planet that won't sit still, and the pressure to adapt has never been greater. The next leap second could be unlike any before, potentially rewriting the rules of timekeeping for the digital age. Our technology is about to face a new kind of test, one that will challenge the very foundation of how we measure and manage time in a rapidly changing world. Earth's spin is shaped by a cosmic tug-of-war. The moon's gravity pulls at our oceans, slowing us down and pushing the moon away. The sun's gravity adds its own smaller influence. Earth's orbit isn't a perfect circle, so our speed changes with the seasons. Down below, earthquakes and melting glaciers shift mass, tweaking our spin. The 2004 Sumatra quake, for example, shortened the day by microseconds. Even deeper, the churning liquid iron core can speed up or slow down the planet's rotation. These forces interact in complex, unpredictable ways. Scientists believe core mantle interactions drive decade-to-decade changes in day length. Our planet's spin is a dance of gravity, geology, and molten metal. For millions of years, Earth's rotation has been slowing, days getting longer thanks to the moon. Fossil corals show that hundreds of millions of years ago, days were just 22 hours long. Atomic clocks let us track this slowdown, leading to the leap second system. But around 2020, something changed. Earth started spinning faster. Record short days followed, overwhelming the moon's braking effect. Scientists suspect changes in the liquid core are behind this acceleration. This isn't the first time, but it's the strongest reversal we've seen. Now, timekeepers face a new challenge: the possibility of a negative leap second. The rules of planetary timekeeping are being rewritten. Earth doesn't just spin, it wobbles. The Chandler wobble, a 14-month cycle, shifts the planet's axis by several meters. Driven by ocean and atmospheric changes, it's usually predictable. But since 2017, the wobble has mysteriously calmed, just as Earth's spin sped up. Scientists think these events are linked, perhaps by changes in ocean circulation or the flow of the liquid core. The vanishing wobble is a clue. Something fundamental is shifting inside our planet. We're witnessing a rare, complex geophysical event. The Earth's motions are more interconnected than we realized. The mystery is far from solved. For the first time in history, timekeepers around the world may need to do something unprecedented. Subtract a second from our official clocks, a so-called negative leap second. This is a radical shift in the way we keep time, and it's never been attempted before. If this happens, it would mean skipping a second on every clock worldwide, causing time to jump forward unexpectedly. Most digital systems and software are simply not designed to handle this kind of leap, especially in reverse. Many computer programs and devices are built on the assumption that time always moves forward, second by second. A sudden backward jump, even by just 1 second, could trigger system crashes, data corruption, and even open up new security vulnerabilities. Tech companies and engineers are sounding the alarm, warning that a negative leap second could lead to widespread outages and confusion across global networks, potentially disrupting the digital infrastructure we rely on every day. The risk is real. Stock trades, power grids, airline schedules, and even satellite communications could all be thrown off by a single missing second, with consequences that ripple through our interconnected world. Some experts argue that the leap second system is outdated and too risky, suggesting we should abandon leap seconds entirely and allow atomic time and astronomical time to drift apart naturally. But if we do that, we risk breaking the ancient link between our clocks and the movement of the sun, a connection that has guided human life for millennia. The debate is urgent and ongoing. Mathematical projections suggest that a negative leap second may be needed sooner than anyone expected, forcing a decision in the near future. Our relationship with time itself is at a crossroads, as we weigh tradition against the demands of modern technology. The next decision we make about leap seconds will shape how humanity measures its days, hours, and moments for generations to come, redefining our connection to time itself. This tiny 1.36 millisecond change is a powerful reminder. Time isn't fixed. Earth's rotation is a living variable, shaped by cosmic and geological forces. Our most precise clocks measure the instability of the ground beneath us. Melting glaciers and shifting iron deep below can change the time on your phone. Our digital world is deeply entangled with the planet's rhythms. The need for a negative leap second shows how nature and technology are intertwined. We must adapt, rewriting code, rethinking time itself. We're not just observers, we're passengers on a spinning, changing world. The shortening of our day is more than a curiosity. It's a lesson in cosmic perspective. As we track these changes, we gain a deeper understanding of the ever-evolving machine we call home.